So I have two visitors here today, but if they're a little bit patient, they'll make their presentations. One is Denise Applebaum, who is over there, and she is our PhD student at advanced stage, not so advanced, at the 4th year, correct?
Right, beginning my 4th year.
Yes. And Denise has been working with Professor Kogan and myself on a paper for the Audit Journal that surveys audit analytics and examines this audit analytics. And June Day, who is here, who is much older in the program, we here in the PhDs, we call age is not chronological age. Age is how long you have been in the program. So June is doing a dissertation looking at audit apps. And I have asked June to come here and talk a little bit about what her proposal was, because I think it's good for you to see what a dissertation proposal is. Second is the kind of thing we're going to talk this semester. That's why I went and attacked the syllabus so badly, and I'm still going to attack it a little bit more, because I want this class to be a modern audit research class, not an old one. And every time I look at that syllabus and I see an article, I say, oh, I really can't get rid of this article. I read it when I was a PhD student, and etc. But I have decided to drop a lot of them, but I can't really drop all the classic articles. I have to leave some of them in there. And what I did is I created, you probably won't notice because of the name of the topics, I created 3 classes to talk about audit analytics out of 13, okay? And that was kind of a transformation I did in the syllabus, and I'm still kind of suffering to this transformation. Now, Blackboard now has the new outline of the course in there. And I still haven't put all the articles I want to put in there. We were in the mid-year meetings of the AAA audit session last week. And it's very interesting how some of the research has not changed at all. And it really has not changed at all. But the other side of it is that there is some evolution of research. And for example, we have this kind of research we do, continuous auditing, analytic audit, was really kind of a totally rejected orphan of research. It's not anymore. Now there is a lot of interest on it. The beginning of the conference, Thursday afternoon was in half day, basically of teaching and analyzing analytic methods. And the big 4, they were all there presenting analytic cases. And so it was very, very interesting to see the evolution, how people are thinking differently already. And a lot of people that kind of the old-fashioned type of research started coming to us, say, what have you been publishing, what tools do you use, et cetera, et cetera. Or the most interesting is, how do you do this in class? And then I started thinking, and I said, and Denise has been starting to do this, is how can we do this in class in the undergraduate?
Right.
And we are going to start doing that very, very seriously. So we are kind of in the stage of change here. And the computer is in the stage of change. Let's see if it starts. So, I don't know if I'm going to have time for doing that, but what I was planning to do today is to show you some slides that a presentation that we did in September for the ASB, to show you an illustration of the kind of modern problems with auditing. And I wanted to show you 2 or 3 slides, a little bit analogous to what I'm going to do this afternoon, on what I call Imagineering. But I don't think we're going to get anywhere with my computer. Look what is doing there. This.
Uh-oh.
Now it disappeared.
I better disconnect it from the get it started first and then connect it to the system there.
Okay, so while we are waiting now to start, I'm going to do something that I've done last year and was good. Is I think a few of you, how many of you never had an audit course?
Ooh.
More than I thought. I thought you would have had an audit course. Let me just talk to you a little bit about the traditional audit steps in the audit. IC is internal control evaluation. These are the kind of traditional steps on an audit. And
Professor, you might want to disconnect your computer from the main system because it might be slow
I
to
did
start.
this.
I mean, like this. Oh, okay.
I'm going to kill my computer and see if it starts again.
Yeah.
And so this is actually a schemata that used as a step of the audit. First question to you is, what's the purpose of a financial audit?
To form an opinion?
Say that louder.
To form an opinion on the financial statements.
Okay, I think the purpose, that's kind of a little bit of a concept. The purpose is to verify if what the company is reporting is reasonably fairly represented. And if it is fairly represented, then you formulate an opinion. Okay? So the purpose is verification. The purpose of accounting is measurement. The purpose of assurance or audit is verification. Okay? And typically you verify according to the standards of that particular country. So a company is reporting their results, they are accordance to GAAP, and you, the person who is verifying it, the attester, have to be independent. So you are not polluted by economic interests of some other reason. So it's according to the measurement standards, according to the way of verifying it, which is the auditing standards, and in addition to that, you are an independent person. Okay, those are the things. So here it is. A company, these are the company's operations. The operations create a report, and then the auditor verifies the report according to if the report was measured correctly, and then you apply auditing standards. And you are independent. Okay, and all of these are subject to evaluation. Okay, I got it started. It's getting there. Okay, so in order to perform this particular set of functions, external audit firms have typically a protocol that they follow, a way they do it. Is they first, before they decide to go on engagement, they evaluate the client. Why would you evaluate the client?
To see if there's any potential risk, if the client may be going bankrupt or litigation risk.
Yeah, and why are you doing that?
To ensure that the opinion that they give is to the best interest of stakeholders.
Oh, why? You evaluate it so you don't get sued afterwards and lose money. Correct? Meaning, if the client is a bum, okay, the best thing for society is that a good independent auditor examines it. Correct? So when an auditor refuses a client, what's actually the auditor is doing is protecting his pocket. Correct? Yes or no? Yeah. So the stage of client evaluation, although it can be presented in lofty terms, is really economic protection of the auditor. Around 60% of all litigation against auditors come from bankruptcies. Okay, because company goes bankrupt, stockholders want to get some money back. Who has the deep pockets is the auditor. And by the way, litigation against auditor has gone down substantially. Now, typically you hear a lot about busy season. And so this is your year. The stages of the audit go, this is the internal control or interim work, and then this is year-end work. And a lot of the work is year-end because you are verifying balance sheet levels. This is what I call the bucket theory of accounting. Every account has an inflow, has an outflow. And so the flows are the income statement. The levels are the balance sheet. The flows happen at the entire year. What you certify is a balance sheet. What is a balance sheet? Is a level at the end of the year. So the reason why you have so much work to be performed at the year end is because you are verifying the balances at that particular point in time. So a balance sheet is point in time. And the income statement is a flow through the period. And therefore, to verify this level, you have a lot of work. This is kind of the simple explanation. And interim work, internal control evaluation work is done at the end during the year because you can do that all the time. So finish up that traditionally auditors are very busy here and less busy here. Therefore, auditors charge less money if you are a client whose year end is through the year, not at the year end, because this is when they are the most busy. Actually, in the old days, I've seen companies charging $5 for an audit because they were mid-year audits that didn't take a lot of resources to perform. Okay, let's see if I can get this thing. is having to work. You like her? You don't like your favorite course. That's my daughter and my dog. You know which one is my dog and which one is my dog? It's not my daughter, my granddaughter, sorry.
Which one do we have to like?
Huh?
Which one do we have to like?
No, certainly you have to like the dog. Then let this on for a second while I finish talking about this. And I am sure a couple of you heard about me talking about this. But, so this step, this set of steps is the following. You decide that the client is not going to, you're not going to lose a lot of money with the client. So you sign an engagement, you make an estimate of fees, etc., etc. You start your engagement. The first thing that you do is you start thinking about how you're going to allocate your resources. These days, the PCAOB insists on you do a risk-based audit. What does it mean, a risk-based audit? Is that you do more auditing, more effort, and more concern in the areas that you have more risk in your audit. And so you decide, you basically look at the different cycles, payroll, purchase to pay, etc., 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 and say, I'm going to put this effort, my effort this way. And then you work on that audit, and then you start, plans are never what really happens. You start discovering things. Certain areas, everything is going very well. Other areas, things are not going so well, so you have to move your resources to that area. Also, things happen during the year, in addition to you discovering things. So you spend some time evaluating the controls. This is the interim work. And if the controls are very good, you can reduce the amount of substantive testing you do. What is substantive testing? Is examining the details. If the controls are mediocre, you have to do quite a lot of this. Now I divided internal control evaluation into two pieces. Internal control evaluation and internal control testing. One is like engineering study. One thing is you look what the plan was. So if the internal control seems to be a nice structure, it's good. But now you have to find out if the company really obeys those controls. So there is two steps. One is the control. If the control structure is junk, no use the company following them very well. It's a little bit of a use, but enough. However, this actually gives you a view of the internal control. The design is good, the compliance is good. Therefore, you have good control, you can reduce your substantive test. So this is kind of the classic way to break down your audit. But you are modern people. What's wrong with this whole picture? Is this good?
What about during the year?
Yeah, exactly. It's not good. It's not good because you have a misallocation of resources here, poor allocation of resources. Also, you're not doing anything of verification for a while. So that's one thing. And actually, what's really happening is that the volume of data is so large that you would like to do a lot of your audit during this time. The other thing is, auditing is not manual anymore. Auditing is very automated because all the data, in old days, data came in what way? Or in papyrus, or in little, yeah. Meaning, there are many other ways. Sometimes you used to accumulate coins that were made of clay and etc., etc. But in the past, recent past was paper documents. Do companies keep a lot of paper documents today? Much less, much less. And so it's all electronic. And so a lot of the rules about source documents going and examining paper, companies don't have paper anymore in source documents. And so this thing is changing very rapidly, and this hasn't changed as fast as it needed. Now, stay there because I'm going to shock you a little bit, and then we'll come back. This is my view of big data, and I kind of go to this the following way. I say you used to collect paper data. Then when paper data started becoming obsolete, you used to punch cards and put them into computers. This is all a manual, inefficient process. About 20-something years ago, people start getting scanner data. What is scanner data? Is barcodes. So this thing, let's see if it has a barcode. No, it doesn't have a barcode. But most things have barcodes. She has a barcode here. So you used to, instead of typing it in, you would to manually scan it. Now, that has an interesting development. The interesting development is that you could link the traditional data that you have to scanner data and discover things like who is buying what are the portfolios, basket goods that people buy, because now you're linking background data to scanner data. Eventually, we went into web data. And what is web data? It's basically information that comes out of your communications over the web. And so with web data, you could actually capture communications from both sides, where you ask for the data and where you receive the data. So you have you standing here, the internet here, oops, and the store here, Home Depot here. And so you ask for the data here, it jumps around in the internet and gets here. Now, here you get a packet, and the packet has IP number, the address of this, address of this. So in this communication, you kind of know who is talking to whom, and you are enhancing, so you can do things like click path analysis. What is click path analysis? It's an analysis whereby you see what people click and what was their decision process. So you know who it is, what they are buying, and what is the decision process to buy, where they went in the website. Okay, now the other thing is that this is totally manual capture, this is scanner, so device capture, and this is totally automatic capture. And you're linking these two, you're adding your understanding of the data. Next one is cell phone data or GPS. Now, it's totally automatic, and in addition to the data that you are generating, it is locational. So you know where the person is. Now, there are two technologies. GPS, you all know what it is according to satellite location. And there is another technology that's based on, I'm not doing very good here. The other technology is based on telephone company towers. So they basically, it's called Jeep. And there are several of them, but Jeep is one of them. And basically by the angle of the towers and the strength of the signal, they know where you are. It's not as good as GPS, but it's pretty close. Now, with these two technologies, mobility, your location is determined. Okay, and that question adds a lot to this. So you put these four things together, how much privacy you have left?
The limit approach is zero.
Is there any privacy left?
Probably
Well, it's kind of an interesting mix because first, if someone would have all this information, there wouldn't be a lot of privacy left. But no one really has all that information, not even the NSA. Okay, so there is an interesting set of questions there that we can raise. Now, I usually say that the large big data receptacles can be classified in three categories. One category is video data. Anything from a security camera in your parking lot to news and videos on the internet or programming, media programming, etc. Then the other part of it is voice, media recording, security recording, telephone recording. And the third one is text, like what?
Emails.
Huh?
Emails.
Email, what else?
Facebook.
Facebook, so social media in general. Okay, and these are not disjoint because there is text sitting below the voice. So if you do voice recognition, you can transform voice into text. Is it good? Not so good, but it's getting there. How about the other one? Face recognition. Okay, you can use many devices that recognize your face, correct? And what face recognition does links images to identification of people. So you are a company, you have a building and you have a parking lot on the back. Put cameras up. That camera sees a person coming in, goes into a database of faces of all the employees that you have, decides if that's an employee or not. Maybe has another database of the faces of the most common clients, decides if it's a client or not. Then the person is carrying something. If the something is a gun, can recognize something else. But what you are seeing here is a mix of different technologies. Technology of camera, technology of face recognition, technology of database of faces, and the technology of interpretation that sees something that looks like a gun, can see if this is an employee or is not an employee, depending what you work. Employee with a gun is dangerous. Employee with a gun, if you are a police station, is not dangerous, etc., etc., etc. What do you notice? What we are doing is piggybacking technologies, one on top of the other, doing something for you. Okay, however, all of this depends a whole set of hardware and software, and the real thing is money. Meaning you are not going to buy an application unless it has some usefulness to you. And the other part of it is that you are accumulating information left and right, but you don't accumulate information that's not useful to you. Now, all this, what I described now, is that accounting data? Is this relevant to an audit? I like when everyone is pensive here. Is it relevant to audit or is not relevant to an audit? Okay, we'll stay with that question, because that's why I'm asking the question. These arrows are what I call bridge technology, technologies that extract things and link to the traditional stores. And I just put a whole set of analytic things that we do that works on this environment. We do text mining and analysis of unstructured data. We model, we visualize, we create dashboards to describe what's happening, and we do basic descriptive statistics. All of them, these are applicable here. Now, This is actually the question I asked you that you were pondering about. This basically links different types of information to the different elements of. This might not look to you, but this is a company and their elements, and basically a lot of these are accounting records. Sales, accounts receivable, inventory, cash, supply chain, and et cetera, et cetera. And these things are linked in some form or the other to the big data sources. Like, for example, if in Facebook people are blasting a product, what's going to happen?
Sales will go down.
Right. And if you notice that the sales are going up when people are blasting the product, what's happening? Something is wrong. Correct? And if the people are saying a lot of good things about the product, you expect the sales to go up, you expect inventory to be moving, and then you develop what we call continuity equations that have delays in it. Say it takes so much time for this to happen, and etc. Also, frequency of mentions is a very good signal for sales and etc. etc. And it's not only sentiment analysis, it's quantity too. Okay, but each one of these key accounts, I could come up with some metric out of big data or out of internal data from the company, which could be big data too, that relates to this. Now a little bit more to make the story a little bit more cogent. How do you audit inventory? Remember, inventory is one of those balance sheet items that you come to the end of the period and you see if what the companies say that they have in inventory is what the company inventory. How do you verify inventory? Yehuda didn't take auditing, but I think he knows how to do that. How do you do that, Yehuda?
1, 2, 3.
Count, physically count. Okay, my wife was an auditor, and she used to audit a refrigerator with meat inside. So he used to put her overcoats and go and count how many carcasses of pig was there, and etc. etc.
I see a freezer.
In the freezer,
Yeah,
yes.
this is a blast
You have done that?
Yes. No fun.
It's no
20
fun.
degrees.
No fun. Okay, so how you count inventory? Now, physical. Now let's suppose that you put an RFID chip on each inventory item. So what is an RFID chip? It's basically a chip that has this number, this barcode on it. And you activate it, sending some frequency of signal to it, and the chip responds with its number. So if you are using EasyPass on the highway, your car goes by, it has a little battery on its tag, and it responds to that frequency, this car passed here. So the original form of RFID is basically just a fixed number that gets sent back. So if you stamp or you put a chip in every item of inventory, you can go from outside, send that signal there, and get each one of them to answer. And you can count how many items you have. So Denise doesn't have to go into the refrigerator anymore. On the freezer, you just get the count. How expensive is that to do?
I think it depends on the type of inventory.
Yeah, that's a very interesting point here. Is this hasn't been done yet because the chip used to be $5, $3, $2, 50 cents, 20 cents, 5 cents, 1 cent. Now putting a chip in, by the way, there are RFID chips you can stamp on your arm. Okay, so now it's more feasible. Companies will not put RFID chips on their equipment for the purpose of auditing.
No.
What they are going to do it for managing the logistics,
Right.
for doing the same things that you used to do in the supermarket, etc., etc. For example, the Home Depot and etc. have self-checkout cash registers. So you go with your card, just scan your barcode, or wouldn't need to if all of them have RFID chips. You just kind of use that for decreasing your cashier costs. So in general, many of these things we're talking about, companies will not do them for auditing. They're going to do that for their operations. But you get it for free for audit. Now, how much does it cost just to take count of inventory?
A lot.
Nothing, correct? It's very low cost. So maybe there is some use to audit every month. Correct? Maybe there is some use to audit every day. Maybe there is some use to audit every minute, every second. Continuous audit every nanosecond. Now let's get a little bit more interesting. Maybe you can put an inventory detector in the entrance of your inventory store. Why would you do that? To identify when inventory is added. You getting the story here? You maybe measure the inventory going out. Why would you do that? Come on, come on. Why would you do that?
To track the sales.
To check with sales, absolutely. So you would match inventory going out to your cash register here. How about going further? Linking your suppliers, the trucks bringing the equipment in, then the equipment going out, the inventory items going out to your clients. Why would you do this? Come on.
You can identify theft. You can
Identify theft,
how long it's going to take to get the
assure sales,
Right.
assure that the
Delivery.
distribution of sales is correct.
Right. UPS does that.
Know if your truck drivers are not stopping to have beer. Okay, know if your truck drivers are not stopping and distributing some of the goods that they are carrying to their friends and to their girlfriends. And goes on and on and on. Now this is a pretty interesting line of thinking here. Is this auditing or this is operations?
Monitoring.
Monitoring what?
Well, you're monitoring the products as they're going through the different stages of supply chain to see whether they're being actually fulfilled the way they're supposed to be fulfilled, whether they stay on the truck to be delivered to the client or the customer versus going someplace else, for example.
Good,
Yeah.
good. And why would you do that?
For compliance purposes within the company.
You are saying very nice management terms, but why would you do that?
Well, to prevent theft, for example, to
Decrease your losses from theft.
provide services to clients, for example, for UPS, you want to know where the products are, so that's why you can go online to UPS now and find where your delivery is, because they track it.
Good, good. So, is this auditing or this is management? Good here. It's both. Actually, they talk about lines of defense. This is traditional terminology. First line of defense, management. Second line of defense, internal audit. Third line of defense, external audit. This whole thinking is getting very confused these days. Because I thought this is an auditing story that I'm trying to tell. But in reality, this is a management and, as Denise said, a continuous monitoring story. And if you think carefully, assurance and monitoring are reasonably similar type of things, except for independence and some other things involved in it. Now, this is just the beginning. And here at the end, I talk about the Internet of Things. What is the Internet of Things?
When every device is connected to the internet, fridge, oven.
There's a study by Goldman Sachs that said by 2020 there's going to be 20 billion devices interconnected in the world, and at that time there'll be maybe less cell phones than there are. Okay, those numbers are totally speculative, so I don't remember them by heart, but we are talking about the tens of billions of devices. Each device is going to have this, their own barcode. That is not a barcode, we call them IP number. What is an IP number?
IP address.
Mr. MIT students, what is an IP number?
IP address.
IP standing for Internet Protocol, and at this moment there are 4 numbers, like 168, 60, 12, 0. Each one smaller than 256, and each communication of the Internet has a source, and the source is an IP number. The moment you turn on your computer, you go to Mr. Rodgers, lend me an IP number, temporary IP number, and you are connected with an IP number. Okay? Now, we are running out of these numbers. As big as 255 multiplied by 255 by 255 by 255, as big as the number, we are running out of IP number. So we are coming up with an IP with 2 more positions. So there are a lot of IP numbers around, each one their own address, and there's going to be these devices everywhere. And you know, the typical story people talk about is my oven talking to my car, talking to my microwave oven, talking to my air conditioning. Okay? But the story is a much more interesting story, or a little bit much more of a scary story, because you can detect location, you can detect identification, you can detect temperature, pressure, movement, and these things can be detected directly or by computation with those numbers. And then I just kind of gave some examples of derived relationship. So for example, if her identification and her identification show up in the same location, they are together. Reasonable, so that's kind of have a big privacy implication, correct? And how fast the police can find out how fast Andrea was driving, okay? And by putting those things together, you can interpret an intention. You might be right, you might be wrong. You can make very sure that the IP number is the right person for recognizing their face. Okay? And you can, in manufacturing, see if something is manufactured correctly or not. And there are hundreds of these derived relationships. And at this moment, we talk about speed, we talked about location, etc., but there are many other physical characteristics that still can be derived. Now, if you put all of this in this overlay here, in this overlay here of structure, you're going to be able to do a lot of inferred relationships. Why are you going to do it? When are you going to do it? You always do things to make money. Even things like physical security is to make money. Correct? You don't want an accident in your facilities. You don't want an employee to be injured. All cost money and reputational defect. So you can link all of them together. And so actually the interesting question to ask in this visioneering story, sorry, I'm going the wrong direction. The interesting thing to ask is, what's going to be this audit of the future? And this is 50, 100 years in the future, progressively. The verification is going to be done in a different way, at a different level. Here we are going to talk about maybe next 10 years or something like that. Just something to think about. There is so much information around here, most of which with the government can have access to it, that there is no more privacy. However, to get information about you costs money. And because you're not so interesting, if you put a bomb in the Boston Marathon, you become very interesting. And from 1 second to the other, the government or someone is willing to spend a lot of money to figure out who you are. But in general, this is not necessary. You know, we had this Malaysian airliner situation. Malaysian airliner disappeared. What happened to the Malaysian airliner? You don't know.
Oh, they disappeared?
Disappeared.
Find it.
Huh?
They couldn't find it, I thought.
They couldn't find it, but what happened to it? No one could find it. Several theories. One, it exploded in the air, fell in the ocean close to Australia, and no one found any pieces of it. The other theory is that some group needed a 777 and kidnapped it, killed everyone around there, and is sitting somewhere in Afghanistan, or etc. And we could come up with intermediate theories. Now, what's really interesting about that, in addition to these scary ideas here, what's really interesting about that is there were about 6 to 8 data streams coming out of this airplane. And we still don't know where the airplane is. Each one of the engines has a wireless data stream that it sends to its manufacturer. There is a black box. There is a locators in there. So how come they don't know where the airplane is?
But doesn't the data go to a satellite, so they know by the satellite location, but they don't know the exact precise location? That's the issue, isn't it?
Intelstat.
Yeah. So they have a huge range of 900 miles or something they have to invest, or maybe more than that.
Yeah, over
Yeah.
the water. They don't have radar over the water of oceans.
But they have data streams from the engines.
But they go to a satellite, that's the tricky thing. Yeah.
And countries have low-range radar, high-range radar. How come they don't know where this thing is?
Somebody knows.
What did you say, Denise?
Somebody knows.
Yeah, that's the first thing is
Yeah.
the US has something called the Strategic Air Command and has this whole set of methods to detect if some country have shot an intercontinental missile against the United States. So how come they don't know where the airplane is? The Chinese have similar things. Okay? The Malaysians have low-range radar. So obviously, maybe someone knows.
Yeah.
Okay, but you know, the US would not like to reveal what their intelligence capabilities are.
Did they find a piece of the plane though, like way across the side of the Indian Ocean?
Now they are saying that that's not a piece
Oh,
of
really?
the plane.
Okay.
It's very difficult to think this is a 777 flap.
Yeah,
The flap is the
okay.
thing that
Not
goes
many
down
would-
like this
Yeah.
when the plane starts landing. We haven't had other 777s crash.
Right.
Okay, and they find the 777 flap in an island somewhere, and now the manufacturer says not theirs. I don't think there are many 777 flaps flying in the ocean, correct? So it's very strange. The whole story is very strange. Okay, but I think some of the intelligence agencies have more information than they are letting know. Okay, the other thing is, why doesn't Intelstat knew where the airplane was? Because they can't make money. They didn't have the need. There is not an application that they can make money to navigate, to figure out where every flying object is. But now they will become much more interested on that, because that was a problem that would have been very useful in many ways to do it. Maybe they can charge the governments for some of that. It's all about, I put an app on if I can make some money out of it. Or the government tells me I need to do it. That's very interesting to think about this, because the story I wanted to tell here is first, these applications are one on top of the other. Typically there is hardware, and then there is a set of applications that you go on top of each other. You don't develop RFID for the purpose of auditing. But as far as you have RFID in there, you can audit, you can do all kinds of other things on top of that. And this has also a cybersecurity implication. Why are systems so porous? Why is it so easy to get into systems? Meaning every place we have cybersecurity attacks. Why? Because no one developed a chip for running your computer that is designed for internet networking in certain conditions. And when you design the application, you might leave backdoors with the purpose of accessing for very good reasons. And then you start putting this application one on top of the other, you finish up with a lot of holes. Because you don't develop the whole layer of applications for that particular Intelsat determining where the planes are. Okay, what you do in modern world is you buy an Intel chip. On top of the Intel chip, you put a computer. On top of the computer, you put an internet connection. On top of the internet connection, you go ahead and do an application that's a face recognition. Associated with that, you have a database of faces. There we go, bam, one thing on top of the other. And these things are not all clean, all them cyberproof, and et cetera, et cetera. And the same thing is equipments fail because they're not designed for that particular purpose. But you can't do modern things. You're not going to develop an application and then develop the chip and then go all the way down. Only governments do that, and usually those don't work very well. It's very expensive. Why do so many of these government projects are so expensive and so difficult to do? Because you don't test things properly, and et cetera, et cetera. It's a very delicate type of situation. Now, my purpose here was to tell you how auditing is. I want to tell you one more little story. Just imagine, remember my schemata with the inventory, and you're measuring it? Now, Ian picks up 50 RFID chips, puts in his pocket, and walks in and puts them on the top. What is he doing? He probably took 50 pieces of equipment, carried it home, and then justified by putting the chips in there. So this is a high-level technological crime, correct? Does that blow your mind? No, because technology give it, technology take everything that you develop technologically. Eventually, you can create some kind of technological crime around it. Safest way to keep a computer without being attacked is what?
Pull the plugs.
Yeah, never turn
No,
it on.
pulling the plug, the computer does not work. You leave the plug in, but what do? You put it with big wall around it and two guys with machine guns in the door. But is that computer very useful?
No.
Not really. The moment you put some wires in there and connect it to the internet, technology is giving you great capabilities. Technology is taking it away because someone can enter that is not authorized. It's always that kind of thing, and there's no reason to stop doing technology, except. And so this is actually sharks surrounding me. And that's what actually technology takes. Okay, that's it for this. Okay, I wanted to show you the IASB slides, but I don't think I have time yet. You like my granddaughter and my granddaughter?
Yeah.
But I want to have the time to have June and Denise present, so I can always continue to do AISB next time. So just one thing about the syllabus is there are articles for next time. They are nicely marked over there in Blackboard, and you need to read them. Okay, and for next time we're not going to do this, but the following time on, I'm going to have you guys doing presentations about the articles, summaries, and etc. etc. Why am I not doing it for next time? Because I want to cover a couple more things before we do that. And typically what we do with this class is there are 3 presenters or 4 presenters summarizing an article. And they are not all fun like this stuff. Okay, some of them very difficult, intricate articles to read, and the purpose here, making you do presentations, is basically to understand and to develop an ability to read articles, summarize them, and discuss them. Okay, and I hope that about half of you will become audit researchers. So that's the whole idea behind this.